Hello once again, everybody. We are finishing up Chapter 6 today with Lesson 4. Yes, this is the last lesson in Chapter 6. And today we are talking about something called a dilation. Now, we have been talking all chapter about transformations and how they change figures. So far we have looked at translations, reflections, and rotations. All of them have one thing in common, and that is they do not change the size or the shape of the figure. So today we're going to look at a dilation, and in a dilation we will be changing the size of a figure. The shape will remain constant, however the size will now change. So the translation, reflection, rotation all had to do with the position of the image. The pre-image and the image were congruent. Now dilations, we're going to talk about the size of them. So let's take a look here. Dilations in the coordinate plane. Dilation with a scale factor of k will be an enlargement if k is bigger than 1. So if your scale factor is larger than 1, it's going to be an enlargement. Okay, what does that mean? It gets larger, enlargement. Okay, a reduction will be when it gets smaller or it reduces in size, thus reduction, will be if it is between 0 and 1, so a decimal or a fraction. And the same as the original figure if it is 1. Okay? So when the center of dilation in the coordinate plane is the origin, each coordinate in the pre-image is multiplied by the scale factor k. So you can get really complicated on where your center of dilation is, and it like I said, it makes things way more complicated. For us, all we're ever going to talk about is the center, or the origin being the center of dilation. So when you do that, our transformation is pretty straightforward. You take your scale factor and you multiply it by all the coordinates in your points. Okay? That's the basics of dilations. So the pre-image and the image are the same shape, but not necessarily the same size, since the figure is enlarged or reduced by a scale factor, and we kind of talked about that already. So, take a look here at example number 1. It says a triangle has vertices A, B, and C. Find the coordinates of a triangle after a dilation with scale factor of 4. Okay, so what you can do is write down kind of that general transformation. X kind of y turns into, and now I'm going to make this specific to the problem I'm doing. So I have a scale factor of 4, so now my x coordinate is going to be 4x, and my y coordinate is going to be 4y. Why did I do that? I'm just multiplying them by 4. Okay, so here's A, which is 0, 0, B, which is 8, 0, and C, which is 3, -2. So now when I multiply those, here's my x coordinate, here's my x coordinate. What do I do to it? I multiply it by 4. Well, 0 times 4 is 0. And 0 times 4 is 0. And I forgot to label this one. It would be A prime. Now, B prime. Here's my x-coordinate, 8. Now 4 times 8 is going to be 32. 0 times 0 is 0. And C prime, 3 is my x-coordinate. 3 times 4 is 12. -2 is my y-coordinate. So this would be -2 times 4 right there, which would be -8. So here would then be the coordinates of my new point. And I'll just make this look a little bit more like a 2. Okay. So 0, 0, 32, 0, and 12, -8. Pretty straightforward. So go ahead and take a look at A under the Got It section. Try that one on your own. I'll be back in a minute to go through it with you. So you should have tried A on your own. It says a figure has vertices W, X, Y, and Z. Find the coordinates of the figure after a dilation with a scale factor of 2. Okay, so again, scale factor 2, so my transformation would be x, y. That turns into 2x, 2y. All right, so w, -2, 4. X is 1, 4. Y is -3, -1. And z is 3, -1. So I'm going to basically multiply all my coordinates by 2. So w prime would be -4, 8. X prime would be 2, 8. Y prime would be -6, -2, and z prime is going to be 6, -2. Here are the coordinates of my image. Okay, so when you have a scale factor and you're doing a dilation, you multiply all of the coordinates or both coordinates by that scale factor. Now, let's try one on the graph. It says a figure has vertices j, k, and l. Graph the figure and its image the image of the figure after a dilation with a scale factor of 1/2. So now the first thing you should notice is I have a fraction as my scale factor, so that's going to be a reduction. If it were greater than 1, it would be an enlargement. So let's start with graphing our points. J is 3, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. K is 10, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay, and L is 8, 2. 7, 8, 1, 2. So that is L. So here is my triangle. That is my pre-image. The figure I start with is the pre-image. So when you see that on the test and they're talking about pre-image, that's what they're talking about, the starting point. Okay. So now I need to find the coordinates of my image. So here is my transformation, x, y. That's going to turn into, now my scale factor is 1/2. So 1/2 of x comes 1/2 of y. Okay. Here's my points. J is 3, 8. K is 10, 6. And L is 8, 2. So now J prime, and they're going to start you off with a tricky one. So I have 3 divided by 2, or 3 over 2, which would be 1.5. 8 divided by 2, or 8 times 1/2 is 4. K prime, 10 times 1/2 is 5. 6 times 1/2 is 3. L prime, 8 times 1/2 is 4. 2 times 1/2 is 1. So here are my coordinates. So let's put them on the graph and see what we think. See if we got any smaller. So 1/2, or 1 and 1/2, are going to be right in between 2 and 3, or I'm sorry, 1 and 2. So 1.5 and 4, 1, 2, 3, 4, right there. That'll be J prime. K prime would be 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. And L prime would be 4, 1. 2, 3, 4, 1. L prime. So here is a figure that is half the size of the, here's an image that is half the size of the pre-image. So again, you multiply the coordinates by the scale factor. And you can see on the graph, the shape stays the same. What changes is the size. The size stays the same. Go ahead and try B on your own. I'll be back in a minute to go through it with you. So here we go, trying B. We have a scale factor of 3. Before I graph either one of them, I'm just going to go through the transformation. X, y turns into 3x, 3y. So I have F, which is -1, 1. G, which is 1, 1. H, which is 2, -1. And I, which is -1, -1. So now I'm going to multiply all those by 3. F prime would be -3, 3. G prime would be 3, 3. H prime is going to be 6, -3. I prime is going to be -3, -3. Okay. So again, I'm just simply multiplying my both coordinates by the scale factor. So let's graph them both on here and see what they look like. So I've got F at -1, 1. G at 1, 1. H at 2, -1. I at -1, 1. Okay, so that'd be I. So this is what my pre-image looks like. This is where I stay, or where I start. Okay, there's my starting point. Now I'm going to graph my image. So negative 3, 3. 1, 2, 3, 1, 2, 3. F prime. G prime would be 3, 3. H prime is 6, 3. 6, negative 3. And I prime is negative 3, negative 3. So here you can clearly see that our center of dilation is going to be the origin. You can see how it expands from the center out, right? Because kind of the center of our pre-image was the origin, so expanded in all directions. Okay. But again, you can clearly see that it is an enlargement, because from the image to the pre-image I got, or from the pre-image to the image, my figure got much larger. Enlargement, larger. Okay. Let's try another one. It says, through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? Okay, so we want to find the scale factor. Okay, we want to find the scale factor. So what we need to realize, or what we need to think about, is one of our examples. So let's say I have the point 1, 2. Okay, we'll just do 1 point. This is my pre-image. Pre-image again is the starting point. I have a scale factor of 2. So I'll abbreviate scale factor, SF. So then my image, multiplying both by 2, would be 2, 4. And the image is my ending point. So I know that I take my pre-image, I multiply it by 2 to get my pre-image multiplied by 2 to get my image. I take my starting point, multiply by 2 to get my ending point. So if I just know my starting and ending points, how do I get 2? Well, to find scale factor, okay, and again, take that note card out and you write this down. Scale factor is equal to image over pre-image. So when you're looking to find your scale factor, you want to take the image over pre-image. Image over pre-image. 2 divided by 1 is 2. 4 divided by 2 is 2. Okay, so that's how I'm going to find my scale factor. So if we take a look back at our example now, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. Okay, now the way it's written, it's hard to tell which one's the image and the pre-image, because they talk about the image of a grain of sand. Okay, so to me, when I read that, I think the starting point, the pre-image, is my 0.25. That's what it actually is. Through the magnification or the enlargement of the microscope, this is what it looks like. So that would be the image. So in order to find that scale factor, okay, of the dilation, we're going to take image over pre-image, or 11.25 millimeters over 0.25. And we're going to see what they multiplied by. So 11.25 divided by 0.25, and I get 45. So what you're looking at would be 45 times larger, or the scale factor is just 45. Okay, 45. Don't forget scale factor, image over pre-image. Now, take a look at C, try that one on your own, and I'll be back in a minute to take you through it. So you should be back from trying this one on your own. Let's go through it. Lucas wants to enlarge a 3x5 photo to a 7.5 by 12 photo. What is the scale factor of the dilation? So this is going to be my starting point. This is going to be my pre-image. This is my ending point. This is my image. If we all recall, scale factor is image over pre-image. Image over pre-image. Now, what complicates this problem is that they give you the dimensions of the photo. So which numbers do you use? You can think of this as like an x and a y coordinate. Okay? This might be your x, this would be your y. This would be your x, this would be your y. The main thing you need to remember when you're dividing is that you line them up. If this is your first coordinate, or this is your first dimension, divide it with your first dimension. Don't take this one and that one. Okay? So in our case, we have dimensions. If this is the short one in the pre-image, this is a short one in the image. Make sure you are dividing those. Don't crisscross them. Okay? Also, you only need to divide one pair of them because it's going to be the same. So if we just take the first one here, image over pre-image, I have 7.5 over 3. 7.5 divided by 3, 2.5. So that would be 2.5 times bigger. My scale factor is 2.5. Make sure you can see that decimal point there, 2.5. Okay, image over pre-image. So now, if you would want to check it, or make sure you did it right, you could take 12.5 divided by 5, and you should get the same thing, and you do. Okay, so that would be your scale factor. Either way is correct. Like I said, just don't crisscross them. All right, here is the assignment for today. Again, red, yellow, green. The choice is yours. Choose appropriately. If you've been doing very well, make sure you do the green assignment. Challenge yourself, push yourself. If you struggled a little bit, do the yellow. If you don't have a clue what you're doing, do the red, and make sure you come in and see me. Okay, watch the video again. Watch it 1,000 times if you have to, and then come in and talk to me. That'll probably be the best way to clear up any confusion. Alrighty, get started on your assignment, and as always, have a great day.